trick to find hybridization and geometry of molecules. Okay, there's a formula using which we can find the hybridization, from which we can find geometry of the molecule. Okay, so first case is molecules containing only one central atom. Only one central atom. Okay, so in this case we can represent n. N will be equal to, first we have to calculate n value. N will be number of valence electron in the central atom. Plus number of surrounding monovalent atom. Okay, number of surrounding monovalent atom. Plus we have to add negative charge if present. Okay, or subtract positive charge if present. Okay, subtract positive charge if present. Okay, so this will be the formula. First we have to find n, from which we have to find n by 2. Using this n by 2 we can find the hybridization. Okay, next, how can we find hybridization using n by 2 value? If n by 2 is 2 means sp, then 3 means sp2, 4 means sp3, 5 means sp3d, then 6 means sp3d2, and so on. Okay, now let us find the hybridization of some compound. First example is SO4 2 minus. Okay, so first we have to calculate n. N is equal to, sulfur is the central atom here. It contains 6 valence electron, plus what about oxygen? Oxygen is a divalent atom, so no need to take that. Next, it contains 2 minus charge, so we have to add 2. Is equal to 8. Okay, so n by 2 is equal to 4. So the hybridization is sp3. Next, second example, ICl2 plus. Here n is equal to, iodine contains 7 valence electron. Iodine is a central atom, contains 7 valence electron. Chlorine is a monovalent atom. 2 monovalent atoms are present, minus, here it is a plus charge, so we have to subtract 1. So the answer will be 7, 8 minus 1, 7, 8, 9 minus 1 is 8. So n by 2 is equal to 4. This is also an sp3 hybridization. This compound is sp3 hybridized. Okay, now next compound, third one, HCOF4. Here we have to find first n value, central atomic xenon, and we know xenon, the valence electron is 8. Okay, plus oxygen is a divalent atom and fluorine is a monovalent atom. So 4 monovalent atoms are present and there is no charge. So this will be equal to 12. Okay, so n by 2 is equal to 6. So the hybridization is sp3d2 hybridization. Okay, so like this we can find the hybridization of different compounds. Okay, second case, molecules containing more than one central atom. More than one central atom. In such cases, we have to use another formula. Okay, that is n by 2 is equal to number of sigma bonds. Number of sigma bonds present, or we can say number of surrounding atom. Surrounding atom gives the sigma bond. So, number of sigma bonds or number of surrounding atom plus number of lone pair of electrons. Number of lone pairs. Okay, number of lone pairs of electrons or number of lone pairs. This is another formula. Okay, here first we have to find n by 2. Let's take one example. In C2H5OH, find out the hybridization of oxygen atom. Hybridization of oxygen atom present. Okay, here the compound is CC like this. Okay, this will be the compound. Oxygen atom, hybridization of oxygen atom we have to find. This oxygen contains 2 lone pairs of electrons. Okay, so first we have to find n by 2. N by 2 is equal to number of sigma bonds or surrounding atoms. It contains 2 sigma bonds. So 2 plus how many lone pairs? 2 lone pairs. That is equal to 4. This means the compound is sp3 hybridized. Okay, so oxygen is sp3 hybridized. Like this we can find the hybridization of molecules containing more than one central atom. Okay. Next, after finding n by 2 value, we can find the actual shape of the molecule. Okay, or geometry of the molecule can be find out using this n by 2 value. First, if n by 2 is 2, then bond pair is 2 and there is no lone pair, we know the geometry is linear. Example, BeCl2, bond angle 180 degree. Okay, if there is no lone pair, the shape will be same, but if lone pair is present, the shape get distorted. So next case, 330 triangular planar, shape is same. Example, BF3, angle is 120 degree. Next, 321, one lone pair is present. So, shape get distorted, angular shape, SnCl2, angle less than 120 degree. Next, 440, no lone pair. So, tetrahedral in shape. Example, CH4, 109 degree, 28 minute bond angle. Next, if one lone pair is present, so 3 bond pair and 1 lone pair. So, the shape will be triangular pyramid, okay, triangular pyramid, and example NH3, angle is less than 109 degree, 28 minute. Next, 422, shade get distorted, B shape, H2O molecule, angle 109, less than 109 degree, 28 minute. Next, 550, shape is trigonal bipyramid, same shape. Example, PCl5, two angles are the 90 degree and 120 degree. Next, 541, trigonal bipyramid get distorted, so the actual shape is CSO. Example, SF4, angle less than 90 degree and less than 120 degree. Next, 532, geometry is distorted, okay, T shape, CLF3, angle is less than 90 degree and less than 120 degree. Next, 523, 3 lone pairs are present. So, get distorted, shape get distorted to linear, XCF2, 180 degree. Next, 660, no lone pair, so octahedral shape. Example, SF6, 90 degree. Next, if one lone pair is present, 651, so shape get distorted to square pyramidal, IF1, angle less than 90 degree. Okay. Next, 642, two lone pairs are present, so shape get distorted to square planar, XCF2, XCF4, example, angle less than 90 degree. Okay. Like this we can find the geometry. Now let us do some examples. Okay. Now let us take few examples to find the geometry of them. Okay. First one, NH4 plus. NH4 plus. Here nitrogen is the central atom. So N will be equal to, nitrogen contains 5 valence electron plus 4 surrounding monovalent atom. Okay, 4. Then minus 1. Plus charge, it contains plus charge, so minus 1. So this is equal to 8. So N by 2 equals 4. Okay, 4 means the hybridization is sp3. Okay, next we have to find the geometry. Nitrogen is a central atom. It contains 5 valence electrons. So plus charge means 1 less. So how many bond pairs present? Bond pairs, it is bonded to 4 hydrogen atoms. So 4 bond pairs. How many lone pairs? No lone pair. Okay. 0 lone pair. So the shape of the molecule is tetrahedral. Next, second example, ICl4 plus. Okay. First we have to find N value. N is equal to I central atom. I is a central atom. It contains 7 valence electrons. Okay, 7 valence electrons. 7 plus 4 monovalent surrounding atom. 4 minus 1 because plus charge, so minus 1. So this is equal to 10. So N by 2 is equal to 5. Okay, next we have to find bond pairs and lone pairs. Okay, it contains 4 bond pairs. Okay, so I is a central atom. It contains 7 valence electron. So plus charge means 1 less. So 4 electrons are used for bonding. Okay, so remaining 1 lone pair. So what will be the shape of the molecule? 5, 4, 1. The shape of the molecule is seesaw. Let us take one more example. CH3 plus. N is equal to valence electron 4 plus 3 monovalent atom minus 1. Okay, so 6. So N by 2 equal 3. How many bond pairs? Carbon. Carbon plus means 3 electrons. Okay, so 3 electrons are used for bonding. 3. So lone pair 0. Okay, so N by 2 3, B bond pair 3, lone pair 0 is triangular planar. Okay, triangular planar in shape. Okay, like this we can find the geometry of molecules using the formula. Okay.